Good morning, my dear students. So today we will solve a second type of problem in a simplex method. Okay. Question is given like this: solve the following LPP, that is linear programming problem, using the simplex method. Okay, they given the maximum of z of equal to 12 x1 plus 16 x2 and subject to a constraint of 10 x1 plus 20 x2 is less than equal to 120, 8 x1 plus 8 x2 less than equal to 80, and where the constraints belongs to x1 and x2 is greater than equal to 0. This is the question they given. So this is about the 12 mark question. Okay, now 10 to 12 mark they may ask you in the direct examination. Okay, so write the given question as it is and check whether the given problem is whether maximization or minimization. Okay, now here they given maximization, so keep it in mind, and also check all the values here right hand side should be positive. Okay, here both the constant values are positive, so that the given problem is correct. Okay, write down as it is, that is maximum of z of is equal to 12 x1 plus 16 x2. Okay, now I will tell this later why we added this 0 s1 plus s2. Okay, next subject to constraint of what it is less than means you add a slack variable, that is s1 and s2. Okay, now it is greater than means that the problem is different. Okay, right here 10 x1 plus 20 x2 plus s1, remember this plus s1 is equal to make it 120. Okay, s means stands for slack variable, and similarly write second equation, that is 8 x1 plus 8 x2 plus s2 is equal to 80. So what we are doing here, just we are adding the slack variable s1 and s2. Okay, now and in the objective function you write the basic variable, that is s1 plus s2 and coefficient is 0. Okay, now if you are 0 into s1 is equal to 0 and this is 0, nothing but is 0, so you will get same answer here. Okay, so just you add 12 x1 plus 16 x2 plus 0 s1 plus 0 s2. This is an objective constraint. Okay, next to solve this method, simplex method, you check the given solution is optimal or not. Construct a table, that is this table is called as an initial simplex table. Okay, right here CBG means coefficient of basic variable, coefficient of objective, basic values and solution and ratio. Okay, construct this table. Okay, and basic values you write here how many values are there, x1 x2 and s1 and s2. Okay, now write here x1 x2 s1 s2 and their coefficient you write. x1 coefficient is 12, right here 12, and x2 coefficient is 16, right here 16, and s1 coefficient is 0 and s2 coefficient is 0. Okay, now any doubt about this and write. Okay, I just you write the whatever they given you write here and write the coefficient of that. And basic values, what you slack variable you add, how many slack variable you are added here, only two, that is s1 and s2. right here s1 and s2, and their coefficient is objective coefficient of a basic variable is 0 comma 0, right here 0 comma 0. Okay, now and here center, how we got here, why we enter these values. Okay, coefficient of x1 is 10, coefficient of x2 is 20, s1 is 1, s2 is not there here, so put 0 here. Okay, similarly second equation, so x1 is equal to 8, x2 is equal to 8, s1 is 0, so s1 is not there here, so s1 is equal to 0 and s2 is equal to 1. I similarly in this solution is given 120 80 120 80 you write here. Okay, now after this you calculate the z of j values. Okay, so z of j is equal to, how to calculate the 0 0 0 means, see this into this plus this into this, you write answer here. Okay, 0 into 10 plus 0 into 8 is equal to 0. Similarly this side 0 into 20 plus 0 into 8 is equal to 0. 0 into 1 plus 0 into 0 is equal to 0, because here 0 is there. If you want to multiply any 0 with any value, you will get 0, so right here 0 0 0. Okay, next step is to calculate the cj minus zj values. So here cj values here and zj values what you got. So 12 minus 0 is equal to 12, 16 minus 0 is equal to 16, 0 minus 0 is equal to 0, 0 minus 0 is equal to 0. So after this is about the simplex initial table. Okay, after constructing this we check whether the given solution is optimal or not. So here maximization problem is given, so all cj minus zj value should be whether it should be come negative or 0, then only the given problem is optimal. Okay, but here two values are 0 but these two are positive you got, so until we have to do this iteration method, these two values should be negative. Okay, now so all values cj minus zj values if it is negative and 0 means the given solution is optimal, then we stop, then we have to find the answer. So here two positive are there. Okay, next step, find the maximum value among the this cj and gj and dark the circle or enter the circle. So 12 16 0 0 is highest value is 16, just to dark the circle. Respect to column you add that. Okay, that you just make it one highlighted, that row, that is this is called as a key element. Okay na, this called as key element column. Okay, just to draw the circle, why we are drawing here, choose the highest value among this Cj minus Za respective column. You highlighted, or you want dark the circle, or even just you put a highlighted. That column is called as a key column element, remember. Okay, and next after this you come to this side. Okay, so just to divide this, 120 divided by 20 is equal to 6, and 80 divided by 8 is equal to 10. So among these highest value you have to among these two, sorry, least value you have to choose. So among 6 and 10 is least value is 6, so that respective column you enter the one line, okay, or highlighted that. Okay, and this row is called as a key element row or key row. Okay now remember, and where the lines, where the points are intersect, that that is called as a key element. Okay now here 20 is intersecting, so that is called as a key element, and this is called as a key row, key column, and this is called as a key row element. Okay, remember this. Okay, next step, so here still two positives are there, and we have to do iteration method till we have to get negative sign here, negative, negative, and zero value, zero, and below that zero value you have to got this Cj minus, then only the solution is optimal. Okay, go to next step, so iteration method. So here come we solve here iteration method also. Okay, in iteration method what we are doing is constructing a new table. Okay, here write the both the, here both values are same before only, before tabular column only. So Cj is equal to 12600, and basic variable is equal to x1, x2, s1, s2. Okay na, how we got this here means here one minute here. Here what we got here intersection line means x2 is entering the variable and s2 is leaving, that you remember. Okay, so what we got intersection line, no, that is x2 is coming in the next table entry and s2 is leaving. So next table you will get s1 and x1, s1 and x1, x2, sorry, x2 you are getting. Okay, so here say x2 is equal to s2. Okay, x2 is equal to x2. Okay, next, so here in the first iteration this values we have to what, how we got here means we have to divide the given that intersection line divided by whole line. Okay, how means here the first line here x2 and s2. Okay, 20 divided by 10 divided by 20 will get 1 by 2. Okay, 20 divided by 20 is equal to 1, and 1 by 20, 1 by 20, 0 by 20 is equal to, right, like similarly I wrote here construction here, right. Okay, so intersection point is in old values is 10 is there, intersection point is 20 is there, but okay now, so 10 by 20 is equal to 1 by 2, like that you have to do. And second column, how we have one formula. Okay, now for entering the new values, so here what formula means, new value is equal to old value minus corresponding key column into corresponding key row divided by key element, then you go on enter here. Okay, I will show one values here. Come here, the old value is here 8, you substitute this in formula. Okay, old value is 8 minus corresponding column value is 8 and corresponding row value is 10 divided by key element 20. Here I got here answer is 4, that 4 you write here. Okay, so this value, this formula you check in the previous table, then apply formula you will get. Similarly 4, second is 0, this is third one is minus 2.5, and 1 is 1. Okay, and similar last column is 80, minus 80 you will get a 30 to this side. Okay, you got new column. Again check zj value, calculate zj is equal to what, this into this plus this into this, you will get a zj value. Okay, 16 into 1 by 2 plus 0 into 4 you will get 8. Similarly 16 into 1 plus 0 into 0, 16, like that you will get like this. After this you calculate the cj minus zj values. Cj is 12 minus 8 is equal to 4, 16 minus 16 is equal to 0, 0 minus 4 y minus 4 5, 0 is equal to minus 0 is equal to 0. Now after completing this box, check whether the given solution is optimal or not. The given problem is maximization. For maximization all cj values should be 0 or less than 0 value you have to got. So this is condition is satisfied, negative value condition is satisfied, this also satisfied, but this is positive, but here also you need negative or zeros you got, then only the solution is optimal. So still it is not optimal, again go for the same procedure for the next, again construct the new iteration method. Okay, here again same you have to enter the values. So here entry, so here choose the highest value. Highest value is 4 here in this column. You dark the one circle with that respect to row. Okay, and right here, and again same similar procedure you follow what you did in the previous. So 6 by 1 by 2 you will get 12, and 32 by 4 is equal to 8. Among these two value, which one is the least? 8 is the least. Again from respect to column you dark the one circle in the element. Okay, so here intersection point is 4, and this is called as key column, this is called as a key row. Okay now, next so here divide by this value. Okay, 4 is there. 4 by 4 is equal to 1. So next table, and 0 by 4 is 0. Again minus 2 by 5 divided by 4 is, you will get a minus 1 by 10. Like that you solve, you will get a new. So here leaving is x2 and entry is x1. So next column is x2 by x1. So what you intersection line, that is entry, and this is leaving. x2 by x1 you write here, x2 by x1. Coefficient is also same, x2 is 16, x1 coefficient is 12, you write here 12. Okay, so again this for x2 values you calculate with the help of this formula. Old value minus corresponding key column into corresponding key row divided by key element. So old value is 1 by 2 minus corresponding key element, key row, this also 1 by 2 into corresponding row is 4 divided by key element is 4. You will get a 0 values here. Okay, like that you solve, you will get these values. Okay, again quotient is right. So now check the CJ ZA value. ZA value how to calculate? 16 into 0 plus 12 into 1 is equal to 12. 16 into 1 plus 12 into 0 is equal to 16. And 16 into 1 by 10 plus 12 into minus 1 by 10. So you will get 2 by 5. Like that you solve, you will get this equation up to 120. This is 128 if you solve this. Okay. Now calculate the CJ minus ZA value. So CJ is 12 minus is equal to 0. 16 minus 16 is equal to 0. 0 minus 2.5 minus 2.5. 0 minus 1 is equal to minus 1. Check whether the given solution is optimal or not. All the values are either should be 0 or negative for the maximization problem. Here we got all the zeros and negative. Therefore the given solution is optimal. Okay now, I understood this. You have to do till this problem until you will get a lesser than 0 or equal to 0. Okay na. So here CJ and ZA values all are got negative and 0. You have to stop here. The given solution is optimal. So what are the values here? x2 is equal to 2 and x1 value is 8 and ZA is equal to what? 128. Okay na, that this is what answer. So I wrote here all CJ and ZA values are zeros and negative, therefore the condition is satisfied, that is x1 is equal to 12 and x2 is equal to 16. Okay, so optimal value ZA is equal to 120. The given solution is the optimal is reached. Okay, I hope you understand this problem. Okay na, thank you.